today we're hosting a meetup with Todor Markov, who is a researcher at OpenAI, and he's working currently on OpenAI API, where he's focusing on safety and monitoring the API. And Todor will share with us about how they use API to fine-tune GPT-3 models. And there will be some exciting live demos as well. So Todor, thanks a lot for joining, and we're very much looking forward to learning from you today.
Yep, thank you, Sophia, for the kind introduction. Hi all. As Sophia mentioned, today I will be talking to you about the OpenAI fine-tuning API. This is a new API which we released a bit over a month ago. It allows you to fine-tune our GPT-3 family of language models on your own data, creating specialized models with much higher performance on their task domain. In this talk, I will give a broad overview of the ways in which fine-tuning can help your concrete use case. I will then run through a live demo of how the fine-tuning API works. And I'm going to talk a little bit about the challenges and lessons learned in the development process for the API. So before we begin, I want to give credit to all my colleagues at OpenAI who contributed to the creation of this fine-tuning API. This was very much a team effort, and the product we have today would not be possible without all their hard work. Now, before I dive into the details of fine-tuning, I'm going to give a brief description of what GPT-3 and the OpenAI API are, in case anyone here is unfamiliar with them. GPT-3 is a family of large-scale language models trained on a vast amount of text from the internet. It was first introduced by us in May of 2020. The models take a sequence of text as their input, and they output a continuation of that text in the same style. This makes them very general. When given a prompt with just a few examples, they can usually intuit what task you want them to perform, and they generate a plausible completion. And this is something that we call few-shot learning. To give some concrete examples, the models can do tasks as wide-ranging as chatbot-style open-ended conversation, summarizing text, sentiment analysis, writing poetry, and many, many others. The OpenAI API is an API we provide that offers easy access to the GPT-3 models. It allows you to build applications on top of our models without having to worry about the complexity of deploying and running them at large scale on physical infrastructure. Now, the base models we offer are quite powerful. However, they do have some limitations. First, there is the question of quality. While the base models can generate text that is often very good quality, there's still an upper bound on how good results you can get purely by engineering the prompt you're providing the models. And unfortunately, for certain use cases, that upper bound can be a little bit short of where you need to be if you want to build a successful product. Second, when you're designing a prompt for some task you want the model to do, you often need to include some examples of the task being done. However, there is a maximum size for the prompt, which limits the size and the number of examples you can incorporate in it. This, in turn, can sometimes limit the performance of the model, especially if your task is really complicated or requires this very long, complex instruction with many different subtle examples. And finally, there is the question of cost and latency. More complicated tasks usually require using our larger and more powerful models, and also require longer, more complex prompts. These factors increase both the cost of executing the task as well as the latency involved. Now, what can we do to address all of these limitations? This is where the fine-tuning API comes in. Fine-tuning lets you get more out of the models that we offer through the API. It improves on few-shot learning by training on many more examples than can fit in your prompt, letting you achieve better results on a wide number of tasks. Once the model has been fine-tuned, you don't need to provide examples in the prompt anymore, and this saves costs and enables lower latency requests. The fine-tuning process is relatively simple. At a high level, it involves the following steps. First, you want to prepare and upload your training data. Then, you train a new fine-tuned model on your data. And finally, you use your newly trained model to solve whatever task you have that you wanted to solve. And now I am actually going to run through a live demo of the fine-tuning API in action. So I am going to switch my screen share to be sharing my full screen and use a terminal as well as show the dataset preparation piece. So let me reshare my screen. Good, can everyone see my screen? Okay, so first I'll start by installing the OpenAI command line interface, which is what we're going to use to kick off the fine-tuning job. And while that's happening, I'm going to briefly describe what the dataset structure should look like. So the data for fine-tuning should have two main fields. One is the prompt field and one is the completion field. So for the prompt field, you want that to be very similar to what either you or your users will be querying the model with at inference time. And the prompt should usually involve the question or task that you want the model to solve for you. And then the completion field should have examples of example completions that you want the model to generate. So basically gold standard of how you want the model to behave or what's the output that you want. So the command line interface has finished installing. So now I am going to prepare our data. So this dataset is a dataset of Yelp reviews, and the task that we're going to be fine-tuning for in this demo, the first task is going to be predicting the polarity of a given Yelp review, whether it's positive or negative. So I'm using this dataset preparation tool that is taking my current data, which is in a CSV format, and transforming it to a JSON-L format, which is what the fine-tuning API expects for the fine-tuning job to run. And also this dataset preparation tool makes suggestions for certain best practices that will improve your data formatting and allow you to get better results from fine-tuning. So in this concrete case, because we are doing a classification task, which is just predicting the polarity of the Yelp review, the data preparation tool is suggesting that we add a separator between our prompt and our completion, which in this case is just our label. The reason why this helps is that it gives a signal to our model, okay, now it's time to do classification, which helps the model orient itself and in practice helps improve the reliability and the quality of the classification results. So I'm going to accept this suggestion. And now we're getting a second suggestion, which is adding a white space character to the beginning of our completions, which are our labels in this case. And I'm also going to accept this. This usually improves performance a little bit, specifically for classification tasks, because it basically fits better with the tokenizer that we use. And I don't want to split my data into training and validation sets because we are just demoing right now. Okay, so we have our data set now, and I'm going to kick off the fine-tuning job. I'm going to use our smallest model, Ada, so that the job finishes faster. Also, a slightly bigger batch size for the same reason. And I'm going to turn off packing because that helps improve classification results. Oh, I had a typo. It's no underscore packing. Okay, our fine-tune is created and the job should kick off very soon. And in the meantime, I will actually show you what the data looks like. So let me make this a bit smaller. And put this in. So as you can see our prompts are just a bunch of different Yelp reviews. And with the prompt separator added at the end to help the model figure out when it's time to do classification. And our completions are just these, just the strings whitespace1 or whitespace2, where whitespace1 matches negative Yelp reviews, whitespace2 matches positive Yelp reviews. So as you can see here, we're not even training any kind of separate classification head for the model. We are literally taking the raw autoregressive model, and then we are structuring our data sets in a way which kind of basically hijacks its capabilities. And in this specific case, very specifically focuses them on this narrow classification task. And we use that to create a specialized model for the task that we want. And in general, that's a lot of how fine-tuning works more broadly, in that you can hijack the model capabilities in this way for a very wide variety of different tasks, and take advantage of the fact that the model has been pre-trained on so much different data from the internet to really use that flexibility to get a pretty competent or high quality fine-tuned model, even if you have a relatively small data set, only a relatively small data set to fine-tune on. Okay, so we are 2 epochs in, so this fine-tuning job should be done in about 2 or 3 more minutes.
I mean, while we're waiting, I see some questions from the chat. Do you mind to maybe?
Yes, yeah,
start,
yeah. go through the questions.
I see a question from Tyler. Can GPT-3 make mathematically correct statements? For instance, I see 2 pandas in the field. Later, I see 4 pandas in another field. In total, I saw 6 pandas.
Yeah, so that would depend on what size of model you're using, and also how complex versus easy is your math problem. So in general, the smaller models do worse, and also larger math problems or bigger additions, more complex operations like multiplication are difficult. So our biggest model, DaVinci, can fairly reliably add and subtract 2-digit numbers, and I think also 3-digit numbers, but starts struggling with larger numbers than that. More complex operations like multiplication are also fairly difficult, even for the big DaVinci model. There are certain weird examples where the models are really good. For example, especially the big DaVinci model is very good at turning things from pounds to kilograms and vice versa. So it can do that fairly well, even with really large numbers. So yeah, the rough answer of the question is depends on the size of the model and also on the complexity of your math task.
So question from Zulkuf, is there any benchmark on how higher the quality is with the fine tuning?
No very rigorous benchmark, and it varies a lot from task to task. Specifically for classification, which is something that I have seen, depending on the complexity of the underlying classification task, I would expect to see an improvement that's anywhere between 10 to 30 or even 40 points, depending on compared to just few shot classification with the models, based on how difficult the underlying classification task was. And also depends a lot on how big your data set is, so on and so forth.
So I see a question from Han Lee. Is the fine-tuning API available on OpenAI page, Playground?
It's not available through the Playground, but you can hit the API endpoints. And I think in the documentation page, you should be able to find the fine-tuning endpoints. And you can also use the command line interface that I'm using right now. Also, it looks like the model has finished training. So I'm going to show some examples of using it in practice. So let's try it out first on a very, very simple Yelp review or mock Yelp review. And it's important to remember to add the separator in at inference time as well. Otherwise, the model will be confused and will get bad results. Okay, so we see that the model correctly classifies this very easy review of "this is my favorite restaurant" as being a positive review. And it also classifies this very easy example of "this is the worst restaurant I've ever been to" as a negative review. And now I'm going to kick off a second fine-tuning job with a slightly more interesting use case, which is open-ended generation of haikus. So we just want to fine-tune our model to generate haikus from scratch. I'm going to use the dataset preparation. Oh, it's prepared data, not prepared dataset. I'm going to use the prepare data tool again. And in this case, I am not going to take the suggestion for adding a white space to the beginning of the completion because we're doing open-ended generation. And I'm going to use the slightly bigger Babbage model so that we get better quality results. So this fine-tuning job is going to take slightly longer to finish. So in the meantime, I am going to go back to sharing the presentation screen, and I will talk a bit about some of the challenges and lessons learned in the process of developing the fine-tuning API. So the first lesson that was very important for me is the importance of understanding who is the core user you are building for and what are their needs. During the development of the fine-tuning API, we had two main kinds of users. The first was software developers with relatively limited machine learning experience. And the second was machine learning engineers with a lot of experience in the field. And now these two groups of users have very different needs. The software engineers usually like having a lot of guidance and a product that just works out of the box. And they want to be able to kick off a fine-tuning job, get their new model, and have it work well without requiring extensive experimentation. ML engineers, on the other hand, like having a lot of flexibility and power in terms of things like specifying lots of different hyperparameters, setting the metrics that they're getting from the API during training and during evaluation, and other things like that. Now, during the initial stages of development, those differing requirements created some challenges for us. Part of those challenges had to do with prioritization. The core technical team for the fine-tuning API work was initially just 2 people and later expanding to 3. So we didn't have the bandwidth to address the needs of both user groups at the same time. But the bigger challenge was actually that the user needs were a little bit in tension with each other, because increasing the power of the API by offering more metrics and hyperparameter options created a risk of leaving people with less experience in machine learning just very confused and overwhelmed, not being sure how to be successful with the product. Whereas keeping things simpler and more streamlined could leave more experienced practitioners frustrated with the limited options they had available. Now, ultimately, the way that we resolved this tension was by making a clear decision that we're going to, at the very beginning, focus on software developers with less experience in machine learning, and that therefore we were optimizing for simplicity and a works well enough user experience, rather than a squeeze out every last drop of performance possible experience. Having this clarity then made it much easier to make aligned decisions about what features to prioritize and what to build next. Lesson number 2 is that users will get stuck in places that surprise you. When we first started expanding access to the fine-tuning API, my implicit assumption was that the biggest pain point for users would be either not having the kind of evaluation metrics they wanted, or not being able to easily compare results across a large number of fine-tuning runs, say 10, 20, 50 different runs. However, this assumption turned out to be quite wrong. The biggest pain point and place that many users got stuck was actually moving their data from the original file format, which often but not always would be CSV, to the JSON-L format required by our API. Doing this was a fairly high friction process for many users, and oftentimes there would be subtle errors in how they would format their JSON-L file. So the fine-tuning job would just fail with a very mysterious and opaque message. So when we first figured out that this was a very common issue that people would run into, I was initially quite surprised because I had always considered this specific operation of changing the data format to be fairly straightforward. But empirically, that was not the case, and people were getting stuck on it a lot. So I think this kind of mismatch really emphasized to us and helped us remember that it's really important to actually continuously be getting lots of user feedback on the product and to really place a lot of weight on that when deciding how to prioritize different improvements, new features, and other things that we wanted to work on next. And this brings us to the final lesson, which is prioritization. So at the time, we discovered that data preparation was a common issue for customers. I was actually working on an approach to improving the quality and reliability of model completions by ensembling different models together. And the reason I was working on that was that we had talked with 1 or 2 customers who were somewhat blocked on this because they needed higher reliability in the model completions in order to be able to use them in production. So I also thought that this would end up being a blocker for a number of different fine-tuning API customers as well. And an additional reason for working on this was that it was a problem that from a research perspective, we thought was quite important. However, as you can probably already guess, given that I'm talking about this, reliability was not in fact a major blocker for the API customers at that time. So ultimately, working on this problem for a few weeks was an incorrect prioritization call on my end. A project that had much higher immediate impact, even though it was far more mundane, was actually building the data preparation tool you saw me use in the demo, which was created by my colleague, Boris. That tool made it significantly easier for our customers to successfully fine-tune models on their own without needing help or advice from us. And enabling that kind of self-serve functionality was a big part of the reason why we built the fine-tuning API to begin with. And it's something that's really critical for us in order to be able to really massively scale this. So this brings us to an important corollary about prioritization, which is that the most important, highest impact work you can do is not necessarily the most interesting or flashiest work. Okay, so now I'm going to go back to sharing my terminal screen. The fine-tuning job is almost finished running. And also, while we wait for it to complete, I can take questions.
Yeah, sure. We can basically continue. I'm going from the earliest to the latest questions. So I see
Sounds
question
good.
from Shubham. Is there any use of, excuse me, is there, uh, the screen, I lost the chat screen, just a second. Is there any use of spreading the data set for fine tuning? Basically, any mechanism where it shows the accuracy numbers on the validation set?
Yes, we do have the optionality for specifically for classification task. There is an option when using the fine-tuning API to specifically calculate metrics such as accuracy, precision, recall, and F1 score on your validation sets. For broader tasks, we can calculate loss, also things like perplexity. I think we actually don't calculate perplexity right now, but it's fairly straightforward for us to add on our end. The main problem there is that usually especially for either conditional generation use cases or open-ended generation use cases, the validation loss that you're getting is not necessarily going to correlate that much with the quality of your final results that you're getting. So for a lot of customers that we have that have more open-ended or generative use cases, in practice, they have some rough, oftentimes what they do is they run an initial spot check on the results that they're getting from the model. And if things look good or better or comparable or better than their current models, they run an A/B test in production.
Mm-hmm. So question from Vlad, what size of GPT-3 are you using in this example that you're just demonstrated to us?
So the specific parameter numbers are technically not public information, but for classification, I use our ADA model, which is the smallest, fastest model we have. And for the haikus generation, I'm using the Babbage model, which is the second smallest that we have, the second smallest, second fastest that we have.
So I see there's another question from Vlad. So he's asking where is there, he can find the ADA specifications. I don't know if it's a public information.
No, the parameter numbers are not public information.
Mm-hmm. Okay. Another question from him, does training procedure update all the model parameters?
Yes, currently that is the case.
Mm-hmm. Okay. So another question, what sizes of fine-tuning data sets are needed to get good results for tasks that you have experienced with? I'm not sure I got this question, to be honest.
Yeah, so in general, the size of the data set that you want, more data works better, but in practice, what we often advise users is to get something very small to begin with. So in the range of 1 or 200 examples, fine tune on that and see how it does. I think for more generative use cases, even 100 or 200 can sometimes be fairly good, or you can start getting okay results for your models. And for classification, usually what we tell customers is try 500 or above. But yeah, you don't need a ton of data to start seeing noticeable improvement in the models. So in these concrete examples, the Yelp review sentiment dataset that I have has 500 examples, and the Haikus dataset has 1,000 examples.
Mm-hmm. Thank you. So I see another question. Can you please elaborate more on the technical background of fine-tuning? Does it train a separate layer in the end?
No, it does not train a separate layer in the end. So it just takes the existing weights that the model has, and it fine-tunes them based on the data set that you have provided. So, and right now, actually, we are experimenting with certain approaches to trying to fine-tune only a smaller subset of the weights, but those are still actively being experimented with. But that optionality might become available maybe 1 or 2 months from now, depending on what our results look like.
Mm-hmm. How would you fine-tune the model for improving its semantic search?
Right. So this fine-tuning API is probably not as well suited for fine-tuning for search tasks, but actually we are some of my coworkers on the applied AI team are working on expanding or on not expanding, but on creating or actually on releasing a API, a more search-oriented API that uses embedding search with models that were specifically fine-tuned for search on a really massive data set. And I think for search use cases, using those models and that endpoint should give very high quality results once it's available.
Just like image style transfer, can we fine-tune GPT-3 for style transfer in text as well?
Yes, that's definitely an example where I expect fine-tuning to work really well. So you can try, for example, fine-tuning transferring short stories in the style of your favorite author. So in the style of Murakami or Hemingway or whoever you want to imitate.
Mm-hmm. In open-ended generation, I'm assuming that fine-tuning model trained on a particular niche will improve the generation of that niche, but will it deteriorate generation on other niche?
Yes, in general, you should expect that models that you fine-tune are going to do much better than the base models on tasks or examples which are similar to the data set that they were fine-tuned on, but significantly worse at anything that's outside of that data set. So we can actually try looking at a few examples with the Haikus model that we just fine-tuned. So oops, I misspecified this. Let's try again. Okay, there we go. Jeremy Bray, The Garnet Boasts, Faux Confinement. Let's try one more. Evening shadows moving closer to the powder keg. So it's not actually following the proper haiku syllable structure, but it does have the general poetry vibe, which is good. But if we try asking it something else, like oh yeah, it continues in haiku style, and it's going to be kind of hard to make it not do haikus now that it has been fine-tuned.
Mm-hmm. Thank you. I see a question from Chinmay. Is it possible to style transfer on large text larger than 2,000 tokens?
So you would need to get a little bit creative with how you'd want to do it. The immediate thing you can try do it is actually just chunking your text into individual 2,000 token windows and then doing style transfer on them one by one. The reason for that is basically just from an input perspective, the transformer models, both base and fine-tuned models, can only take up to 22,048 tokens. So any kind of text larger than that needs to be split up into parts and processed separately.
I see a question from Ankur. If you're updating all the weights, then how are these models cheaper?
So usually the reason why it ends up being cheaper is a combination of two things. One is that oftentimes your prompt becomes much smaller. So for example, if I want to have GPT-3 write a haiku, or the base GPT-3 write a haiku, or do classification for me, usually I need to give it a few examples in the prompt. And for any new generation I want, those examples still need to be in the prompt, which means that my prompt ends up being, say, at least a few hundred tokens. And since the cost of the models is on a per token basis, if with fine-tuning, you don't need to stick examples in your prompt. So if your prompt is 10 times or 20 times smaller, just the cost of running the model becomes much lower because from your perspective, because your prompt is smaller. And then the other reason why it often helps with cost is that what we have seen with a number of customers is that they can get comparable or better performance with a fine-tuned Curie model than they had with their prompt engineered Da Vinci model. So oftentimes people can switch to using a smaller model that's fine-tuned while still keeping or improving their level of performance. And those smaller models also cost less.
Mm-hmm. Another question from Chinmay. Can you elaborate on how to use A/B testing to test model quality in production?
So for example, how a former user or a former customer of ours, Replica, would do it is they would just have separate, and their service was offering a chatbot, and their customers could like or dislike the chatbot completions. So the way they set up their A/B test was fairly simple, where they would route some of their customer traffic, or they would split their customer traffic across multiple different models, and then see which models were getting the most likes or the most engagement. And I believe AI Dungeon does something similar. So basically the way you do it is you split your customer traffic across different models and then figure out what are the metrics that you actually care about optimizing in your product. And then you track them, see which of the models you're testing works better on those metrics.
So I see a question from Daniel. Doesn't fine-tuning all weights require storing a copy of all weights? Isn't that expensive?
That is correct. It does require fine-tuning on all weights, but actually storage costs are compared to the training and more so serving model costs are pretty low. And in practice, also likely what we're going to be doing in the future is we're only going to be keeping around for a very long time models that our customers are actively using in production and hitting with traffic. So experimental models are just going to stick around for some time, but then if the customer isn't actively using them, we're likely going to archive them or switch them to a much cheaper storage space. So that's the way that we resolve that specific problem. And in practice, it hasn't really been an issue so far. We don't expect it to be an issue within the next year or so.
I see a question from Chinmay, but Chinmay, do you want to ask directly? I'm not sure I understood your question.
So my question is, how do we teach GPT-3 about recent topics, since GPT-3 is trained uh, on like web data earlier than 2020?
Hmm. Yeah, the way you would go about it is just um, figure out the specifics of or actually, if you want to do a broader fine tuning or refreshment run, what you can do is just do a fine tune in the style of open-ended generation, where your prompts are empty and your completions are the text you want to fine tune on, or the text you want to use to refresh, and just structure the fine tuning in that way. So one example would be to just do a scrape of news articles since 2020 and split those up or chunk those into individual examples with empty prompts and the completion being the news article, and fine tune GPT-3 on that.
Mm-hmm. So are 200 examples enough to fine tune all weights well? Have you tried to only fine tune a few layers?
I don't think we have experimented with only fine tuning a few layers. We do, as a matter of fact, we've had customers who fine-tuned a model on, I think, 800 or 900 examples and got performance on their specific task that was 20% higher than what they were getting with the base prompt engineered Da Vinci model that they were using before. So yes, I think even when fine-tuning the full weights, uh, just a few hundred examples often are enough in practice to get very promising initial results. So, of course, as with most things machine learning, more examples help, and you continue getting increases in performance the more data you feed the model.
Okay, there's a question about price. What is roughly the price for fine-tuning the biggest model on 100 samples of 1024 tokens each?
I don't have the per token costs off the top of my head, but they should be listed on our API page. And fine-tuning costs for fine-tuning for per token costs for fine-tuning are 5x what they are, or at this current point in time, 5x what they are for base models. But this is still quite preliminary, and you should expect changes in how this pricing structure works out as we get user feedback, and also as we figure out how are people deploying and using the models in practice.
Mm-hmm. Can we fine-tune a language to improve its performance, such as Dutch?
Yes, that should be very doable.
Mm-hmm. I don't see other questions in the chat. If you guys have questions, you can unmute yourself and ask Todor directly if you wish.
So to train for different languages, would we go about using empty prompts and the completion prompt of that language?
Yes, I think that's the best way to start off with it, especially if you don't have a very concrete task that you have in mind for that language. You just want to improve the model's general capabilities.
I have a question. So currently there are, I think the limit is 10 per month, right? So
Yes,
does
that's
that
correct.
mean that in a given month I can train 10 models and next month I can train 10 more? Or is that the scenario, or like overall we have to have 10 per month?
No, the first thing you said, you can train
Okay.
10 models this month, 10 models next month. And also, if you hit the limit, you can always just contact us and ask for a extension on the limit. We don't grant all of these, but we grant a fairly large number of these. So it's no harm in just talking with us about it.
Thanks.
There are many people who really want to work at OpenAI. Any tips you can give them besides applying through the website? Is there anything else they can do, to show their skills and that they're valuable?
Yeah,
Mm-hmm.
I think things that we tend to value fairly highly are just project work that's on GitHub, either on personal deep learning projects that you've worked on, or things like paper re-implementations. That's the kind of thing that we like. And more broadly, just having solid software engineering and research engineering skills is basically the way to both get noticed and then do really well on the interviews.
Mm-hmm. Are you guys organizing any meetups? When you I remember before pandemic, OpenAI had those hackathons, all those kind of things where people could come, right, and show their skills. Is there any plans of doing something like that virtually?
I don't know. Oh, yeah, I'm not sure if we have plans for doing anything virtually. We have been sponsoring a number of hackathons around GPT-3, and I expect that we're likely going to do that with Codex models as well. So also a lot of those often end up being in collaboration with other organizers. So actually, if Bugout wants to host a Codex hackathon, you should reach out to us and we might be able to make that happen.
That's great. Yeah. If there are no other questions, I think we can finish for today, right? And Todor, if your research is an ongoing process, if in the future you will have new results and would love to share with us, we would really love to host another meetup and learn more about the progress that you guys made.